So these kids decided to do statistics on balloons. Yay! All right. The average decrease in circumference, and we're talking about decrease in circumference. Okay. All right. Let's do inference. Guys, all of your formulas are in your book in 10.2, so I'm not going to go through the process of writing formulas down. I'm just going to use them. Also, do not forget about your assignments for 10.1 and 10.2. Those will also be due when you come back. Here we go. H. How about P comes before H? Silly P. All right, P. What is our parameter of interest? Our parameter is the mean difference in decrease of circumference. Yay. What does that look like? Let's go mu sub helium. Let's see. Minus mu sub air, I guess. Sorry. Right, so that's what we're looking at. So we'll come up with a hypothesis. We think that mu sub h minus mu sub a would be 0, right? If there is not any decrease. But mu sub h minus mu sub a. And what do we want to know? We want to know, is there evidence that helium-filled balloons deflate faster? So if they deflate faster, then we should get a number less than 0, right? Decrease, it's not the circumference, but the decrease in circumference. So that's the case. Because, okay, they're actually measuring the amount that their circumference is decreasing, not the circumference. So if they're measuring the circumference, then what I wrote before would be right. But they're actually measuring the amount that it decreases. So there's our hypothesis. Our favorite part, A, let's see, is n sub h. How big is n sub h? How many helium balloons did they get? 30. Yes. Oh, that's so nice. Hey. I can just say that n sub h is equal to 30. Check. And I can say that n sub a is equal to 30. And I can say we can assume the distributions of both types of balloons are approximately normal. So since we can assume that they're approximately normal, we can continue with a two-sample t-test. We will perform a two-sample t-test. That's the end part, right? So N is right there. T. Let's do our test. All right. So our test is gonna look like this. T. I'm not gonna write the formula. The formula is in your book. We're still gonna test it against 0. So I need less. Helium was 2.65. So actually, since I haven't written the formula down, I'm gonna write it for you. So we're gonna go mu sub h minus mu sub a minus 0 divided by the square root of we're just going to take s of 1 over n sub h plus s of 2 over n sub h. And that's and this should be squared. Okay. Hey, this formula is on your formula sheet, okay? You can piece it together from your formula sheet. It's not there, like, actually, I believe exactly that is on your formula sheet. So your standard deviation can be found on your formula sheet. There. And then you have to kind of work through the idea of what's going to go on the top, what your statistic minus parameter is going to be, okay, on your top. All right, let's plug some stuff in. So I believe this was 26 point, I can't remember. If you look at your original problem, the average decrease in circumference for helium was 26.5. The average decrease of air-filled balloons was 2.1. I think that's probably going to ask. And our standard deviation of the decrease in helium was 1.92. We're going to square that, divided by 30, plus, and the standard deviation for the decrease in circumference of the air-filled balloons was 2.79. Okay, we're going to calculate this test statistic, and we're going to get approximately 39.46. Yay! Gosh, that's a big number. That's fine. I mean, that is huge, right? for a test statistic, usually our test statistics are like 5 is really, really big, right? That's really, 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 really big, right? So now let's go ahead and go to our calculators and put this stuff in the calculator. So I can just use my calculator for this because I don't have to put in a list. Come on now. Oh. So menu, statistics, stat test, 2-sample t-test. We're not going to use data, we're going to use statistics because we have all that stuff. So X bar, so one was 26.5. 1.92, 30, and then 2.1. Oh, really? 2.79 and 230. And we want that helium is greater than air. All right. I was really most interested in this p-value that comes out. We've already calculated everything else. We already had all that stuff. I just wanted to see the p-value that our calculator spit out. It's pretty much never going to happen. It's like p-value so small that given the data that we have, right, the likelihood that we would get a value as extreme as we had is almost 0. You could pretty much say that that's approximate. So I don't know. I don't even want to write that number. I'm like, it's gonna take me like. It's probably going to take me a minute to write that. Well, yeah, I mean, if I was to write all the terms, yeah, for sure. Do you want to put it in scientific notation? You would. You would. All right. So we are looking at the probability that T is greater than 39.46, which you can literally say that. You can, if it's that low, if it's that small, you can literally say it's approximately that. It's just nothing. I mean, to the 40th power, that's like, yeah, so like 1 in a, I don't even know how to say that number. A number with 40 zeros at the end? Or, well, no. Just kidding. So we will reject the null hypothesis at any O level, at any alpha level, right? Well, let's just stick with the alpha. That was 0.05. So S, in context. What in the world were we talking about? Sometimes I get so...
Heroin.
No, dude. Evidence that helium balloons deflate faster than air-filled balloons. Yes, they do, right? There is convincing evidence that can I just I'm going to do it. English is cheap. The auction ended 13. But I've like pretty much brand new Shimano's like $27. And with my current cycling shoes, I bought when I was 19 years old. Which is a testament to Shimano makes a very good cycling shoe. I didn't want to endorse a product on my video there. I did? Hey, Shimano. Very good shoes. Yeah, cool. I was allowed to say that. I just had to check my answer to see. It's a pretty bold statement to me. And then I already did the B part, right? Interpreting the p-value when we looked at it, right? That given the data that we have, right? The probability that that mean difference is 0 is so low. It's really unlikely that would actually happen by chance. Right? I'm not going to write it down. That's that. 10.2 is done.